Hi, I'm Theo, I am from Brazil, and this is nuclear fusion and fission, two ways to create nuclear energy. First, let's talk about nuclear fission. What is it? Nuclear fission, normally done with uranium-235, is where you give it a neutron, which turns into the unstable uranium-236, which breaks, splits, and starts a chain reaction with the neutrons resulting from the break. Nuclear fission is involved in all current uses of atomic energy on Earth, may them be bombs or power plants. It generates more nuclear waste than nuclear fusion, and 29 countries currently have nuclear fission power plants. 2 of them Brazil with Angra 2 and Japan. Now let's move on to nuclear fusion. It is not yet possible to use it as a source of energy due to the temperature required to produce it. It can only be made with nuclei that when fused will create a nucleus lighter than iron-56 or nickel-62, because elements heavier than both will retain energy, costing rather than producing it. It produces more energy than nuclear fission and is also cleaner. Atomic bombs made with this method, also known as thermonuclear bombs, require a fission process to start the fusion for the explosion. It is theorized to be possible to make a pure fusion bomb, though it is not yet possible. Now let's move on to the next slide. Why are nuclear fusion power plants not yet possible? Nuclear fusion power plants are not yet possible due to the temperature required to cause the fusion, which has a minimum of 100 million Kelvin, which is 6 times hotter than the sun's core temperature. It is not yet reachable without a fission process, which is why it is normally used in bombs, as the fission process causes an explosion with the fusion process. Now, let's move on to the next slide. What is thorium? Thorium is a chemical element 2 atomic numbers before uranium, which is currently used in all nuclear power plants and weapons. It is theorized that thorium can substitute uranium in producing nuclear energy, as it is less wasteful. There's 3 times more of it in the Earth's crust than uranium, and it can produce more energy than uranium. Numerous countries have studied the use of thorium, though tests are not made to the lack of funding and high costs. The Indian government, though, say that thorium will provide 30% of the energy for the whole country up to 2050. Now, let's move on to the next slide. The pure fusion bomb. The pure fusion bomb is a theoretical thermonuclear bomb, which uses only the fusion process, skipping the first fission explosion. This fission explosion that caused the thermonuclear bomb to go over the 100 million Kelvin mark to start the fusion. The pure fusion bomb would need this fission explosion, and it will liberate twice as much nuclear waste, though the impact will be smaller, because the fission process causes a bigger kinetic energy, contributing to the impact of the bomb. Now let's move on to the videos. This is the video of the thermonuclear bomb Castle Bravo, the first one to be tested when she was tested. Its impacts were massive, though the Russians claimed that the Tsar Bomba had an even bigger potential if they didn't stop producing it first. And this is the nuclear fission process. As you can see, there is the nucleus made of protons and neutrons, in which an accelerated neutron will make impact, causing it to become unstable, and thus exploding, forming smaller parts and leaving neutrons. These neutrons will enter in contact with other nuclei, which will make them unstable and cause a chain reaction. And now these are my reference views. If you want to check them, you should pause the video and see carefully. And now, thank you. Thank you for your time, and have a nice day. My name is Theo. I'm from Brazil in 9th grade, and thank you.